squeeze theorem, which is the squeeze theorem. So state natin, let f, g, and h be defined on an open interval I containing A, except possibly at A such that, so meron tayong dalawang conditions na kailangang isatisfy. So yung una, f of x is less than or equal to g of x, which is less than or equal to h of x for all x element of that interval except A. Okay. So, in this case, ini-ignore natin kung ano yung mangyayari sa A kasi ang i-consider natin sa theorem na ito ay yung mga limits as x approaches A. So, dito sa first condition, anong ibig sabihin nito? Geometrically, si f of x ay nasa baba ng g of x kasi algebraically yung mga values ng f of x natin ay less than or equal sa g of x. Similarly, si g of x geometrically nasa baba siya ni h of x kasi algebraically yung values ni g of x ay less than or equal kay h of x. So, try nating i-illustrate yung first condition. So, technically, pag i-illustrate natin yung first condition, meron tayo nitong figure 1. So, yung graph ng f of x ay nasa baba. So, siya yung nasa pinakababa. And then, si g of x, nasa taas siya ni f of x. And then, ang nasa pinakataas ay si h of x. So, ito yung sinasabi natin na f of x is less than or equal to g of x is less than or equal to h of x. So, ito yung ating first condition. Pero, dito sa figure na to, syempre, obviously, yung limits ng g of x, f of x, and h of x are all unequal. Okay. Next, tignan natin yung second condition natin. So, yung second condition, sabi niya, limit ng f of x as x approaches A is equal to L. And yung limit din ng h of x natin as x approaches A is equal to L. So, technically, yung limits nung dalawang lower and upper functions natin as x approaches A ay equal. Okay, so kapag na-satisfy natin yung first and second condition, pwede nating i-conclude na yung limit ng g of x as x approaches A is also equal to L. So kung i-imagine nyo, kasi nga yung limit nung dalawang bounds na function natin, f of x and h of x ay may equal na value. So, technically, yung limit ng g of x din natin as x approaches A ay ma-force doon sa parehas na value na yon. So, kung itatry nating illustrate yung number 2 at saka yung yung conclusion ng ating squeeze theorem, ito siya. So, nasa baba pa rin si f of x. Nasa taas si h of x. So, sila yung dalawang bounds na functions natin. And then, nasa gitna si g of x. So, kung mapapansin nyo, na-squeeze ni f of x at ni h of x si g of x. And yung limit nila, technically, dun sa yung tatlong functions ay equal. Okay. So, try natin gamitin yung squeeze theorem dito sa mga susunod na examples natin. Use squeeze theorem to evaluate the limit of x raised to 4 times the cosine x as x approaches 0. So, kung una nyong makikita tong problem na to, so technically, siguro unang papasok sa utak nyo, pwede natin gamitin yung past or previous na limit theorems natin. Kunwari yung product of two functions. So, paano yung product of two functions? Kukunin natin yung limit ng x raised to 4 as x approaches 0 times the limit of cosine of 1 over x as x approaches 0. Pero, kung titignan natin, hindi natin pwedeng gamitin yung limit theorem na yon kasi dahil dito sa mga to. So, yung number 1, limit ng x raised to 4 as x approaches 0 equal to 0. So, technically, wala tayong problem dyan sa first limit. Pero, tingnan natin yung second limit natin, which is the limit ng cosine 1 over x as x approaches 0. So, take note, as x approaches 0 from the right, yung 1 over x natin, ina-approach niya si positive infinity. And then, as x approaches 0 from the left naman, yung 1 over x natin, ina-approach niya si negative infinity. Okay. So, ano ba yung value ng cosine 1 over x natin kapag ganyan na ina-approach niya si positive infinity at saka si negative infinity? So, technically, yung value ng cosine 1 over x natin, nag-fluctuate lang siya between the values negative 1 to 1. Okay, so since nag-fluctuate siya from negative 1 to 1, then ibig sabihin yung limit ng cosine 1 over x natin as x approaches 0 does not exist. So yung DNE dito class, ang ibig sabihin yan ay does not exist. Okay, so since hindi does not exist yung second na limit natin, hindi natin pwedeng gamitin yung limit theorem regarding the product of functions. Okay, so pag hindi natin pwedeng gamitin yun, pwede naman natin gamitin yung sa squeeze theorem. So, pag gagamitin natin yung squeeze theorem, kailangan nating masatisfy yung dalawang conditions. Okay, so yung first condition, kailangan nating maghanap ng dalawang functions, yung f of x and h of x, where f of x is less than or equal to g of x, and that is also less than or equal to h of x. So, pag maghahanap tayo ng functions na f of x and h of x, so, kailangan muna nating malaman kung ano ba yung, kung saan tayo magsisimula. So, kung saan tayo magsisimula, dapat yung alam muna natin. Ano ba yung alam natin? Alam natin na si cosine 1 over x ay less than or equal to negative 1, and cosine 1 over x is greater than or equal to negative 1 but less than or equal to positive 1. So, etong part na to, pakibalikan yung trigo functions nyo. Kasi 'di ba ang cosine, ang least na possible value niya ay negative 1 at yung greatest naman na possible value niya din ay 1. So, lagi to. Cosine, ang least na value niya ay negative 1, ang greatest value niya ay 1. So, technically, that is true for all x not equal to 0. So, not equal to 0 kasi hindi pwedeng mag-0 yung x natin dito kasi nasa denominator siya. So, yung x natin, of course, dapat siya ay isang real number. Okay. So, ang goal natin, mapalabas natin si g of x doon sa ating middle function. Okay. So, ang g of x natin ay x raised to 4 times cosine 1 over x. So, dito, sa condition na yan, meron na tayong cosine 1 over x. So, ang gagawin lang natin para mapalabas natin si g of x ay kailangan nating mag-multiply ng x raised to 4. So, pag nag-multiply tayo ng x raised to 4 sa middle function, lalabas si x raised to 4, cosine 1 over x. Dapat mag-multiply din tayo ng x raised to 4 doon sa left and right. So, negative 1 times x raised to 4, lalabas yung negative x raised to 4. And then 1 times x raised to 4, meron tayong x raised to 4. So, technically, itong nasa left, siya si f of x. And then, yung nasa right naman, siya si h of x. So, nakahanap na tayo ng values ng f of x and h of x. Na-satisfy na natin yung first condition. Next, tignan natin yung second condition. So, pag second condition, dapat yung limit as x approaches 0 ng f of x ay equal sa limit ng h of x as x approaches 0. So, i-check natin. So, limit ng f of x as x approaches 0 is equal to the limit of negative x raised to 4 as x approaches 0. And alam natin na yun ay equal lang sa 0. Next, tignan naman natin yung limit ng h of x as x approaches 0. So that is equal to limit ng x raised to 4 as x approaches 0. And that is equal to 0. So yung limit ng f of x natin ay equal lang din sa limit ng h of x, which is equal to 0. So nasatisfy din natin yung second condition. Since nasatisfy natin yung first and second condition ng squeeze theorem, then pwede natin gamitin yung squeeze theorem. So by squeeze theorem, the limit of g of x as x approaches 0, which is equal to the limit of x raised to 4 as x approaches 0, limit ng x raised to 4 times cosine 1 over x as x approaches 0 is equal to 0. So yung limit ng g of x equal sa limit ng f of x and limit ng h of x. Okay. So remark, squeeze theorem holds if x approaches a is replaced by x approaches a from the right, x approaches a from the left, x approaches positive infinity, and x approaches negative infinity. Okay. Tingnan natin yung next example. Use squeeze theorem to solve the following. So, limit ng sine x plus 3 cosine x all over x as x approaches positive infinity. So, again, kapag gagamit tayo ng squeeze theorem, kailangan nating masatisfy yung dalawang conditions. So, yung first condition, kailangan nating maghanap ng f of x and h of x such that yung g of x natin ay greater than or equal to f of x and less than or equal to the h of x. So take note, dalawang functions yung prominent dito sa sine x plus 3 cosine x over x. So yung dalawang functions na yon ay si sine x at saka si cosine x. So ano ba yung bounds ng sine x and cosine x natin? So pag i-recall natin yung trigo functions natin, si sine x, ang least possible na value niya ay negative 1. At ang greatest na possible value naman niya ay 1. So, syempre, si x, siya ay isang real number. Similarly, si cosine x, ang least possible value na din ay negative 1. And then, ang greatest value naman na pwede sa kanya ay 1. Okay. Pero, take note, yung cosine x natin, doon sa original function, meron siyang kasamang 3. So, 3 cosine x. So, magmumultiply tayo doon sa middle function ng 3 para mag-arrive tayo sa 3 cosine x. Of course, kapag nag-multiply tayo ng 3 doon sa middle function, dapat mag-multiply din tayo ng 3 doon sa left and right side. So, negative 1 times 3, meron tayong negative 3. 1 times 3, meron tayong positive 3. Okay. Pero take note, ang hinahanap natin ay sine x plus 3 cosine x all over x. So, ang gagawin natin, ipagko-combine natin itong dalawang to. Okay. So, paano natin siya ipagko-combine? Una, kailangan natin silang i-add. Okay. So, sine x plus 3 cosine x. Since pinag-add natin yung dalawang middle functions, syempre ipag-add din natin yung kanilang corresponding functions na nasa left and right. So una, yung left, so negative 1 minus 3. And then yung sa right naman, 1 plus 3. Okay. So negative 1 minus 3, that is negative 4. And then 1 plus 3, that is equal to positive 4. Take note, yung g of x natin, meron pa siyang all over x. So magdi-divide tayo ng x dun sa middle function. Of course, kung ano yung ginawa natin sa middle function, gagawin din natin siya doon sa left and right side. So magdi-divide din tayo ng x sa left at saka sa right side. Okay, so take note, yung x natin, ina-approach niya si positive infinity. Okay, hence, the inequality symbol remains. Kasi, yung dinedivide naman natin na x ay sure tayo na positive. So, never siyang magiging negative. Kasi, kung ire-recall natin, di ba, kapag magde-divide tayo, or magmumultiply ng negative sa isang inequality, yung inequality sign niya ay magiging mababaliktad. For example, recall lang to ha. So, recall. Kunwari, given tayo ng x is less than or equal to 1. Kapag nag-divide tayo ng negative 2, both sides, dapat yung final answer natin, mababaliktad yung ating inequality sign. So, instead na less than or equal to, magiging greater than or equal to na siya. Okay. Okay, next. So, nasatisfy na natin yung first condition natin. Nakahanap tayo ng f of x natin, which is equal to negative 4 over x, and h of x, which is equal to 4 over x. So, yung next na kailangan nating isatisfy ay yung second condition. So, dapat yung limits ng f of x natin at h of x ay equal. So, i-check natin. Limit ng negative 4 over x as x approaches positive infinity. So, negative yung ating numerator, and then yung x naman natin ay palaki ng palaki. So, kung lumalaki yung denominator natin, technically, yung buong fraction natin, yung value ng buong fraction natin ay nagde-decrease. Or, ina-approach niya si 0. Okay, so negative 4 over x, x approaches positive infinity. So, ang limit nun ay equal sa 0. So, yung limit naman ng h of x natin, similar lang din. So, 4 over x, si x, lumalaki yung kanyang value. So, kapag lumalaki yung kanyang value, yung buong fraction natin, palapit siya ng palapit doon sa 0. Kaya ibig sabihin, yung limit ng buong fraction ay equal sa 0. Okay, so nasatisfy din natin yung second condition na yung limit ng f of x natin ay equal sa limit ng h of x. So by squeeze theorem, yung limit ng sin x natin, sin x plus 3 cosine x all over x as x approaches positive infinity is equal to